Hey, it's TJ with smokescreendesign.com. Doing another video today about being accurate with our measurements and what we do when making observations and talking about the flat earth versus the globe earth. So this is a picture that we have used, which was created by I can't even really tell. The text is so small. Can't tell if that's Kanki or something. Sorry. But this was made with AutoCAD to make sure that things were accurate in measurements. And it's been a very good picture to use. And we use this to see the drop in curve. We have the point of the observer, and then the location of the drop. And with this, we've been able to not only visually see, but also have numbers to be able to tell the drop in the curve. Now, one thing that we have been making a mistake in doing is this point here is not equal to the drop in curve. In order for this drop in curve to be the same as the wall, like in this case, I mean the curve would have to come out to here. And so what does this mean? What this means is that one, we want to be accurate in what we're doing. And here's an example. There's that story of the baby that was born by the Taiwan mother, and that flight people have been using to say it proves a flat earth. They say it does not make sense on a globe, it makes sense on the flat earth, therefore absolute proof that the earth is flat. Well, the problem with that is none of those people looked on a globe to see if that was true or not. So that's a problem. And so back in October I made a video showing that using Google Earth, if Google Earth would be an accurate model for a globe, that it makes sense to travel up to Alaska and not through Hawaii. Well, there are some people who believe that it is worth still sharing the story, even though it's been proven to be wrong, because one, it gets people to believe in the flat earth, or number two, it gets people to look into the flat earth, even though it's wrong information. And that's a problem for me, especially because someone that may believe in the flat earth may take that to someone who does not believe in the flat earth and show them as proof. And then if that person who does not believe in the flat earth goes and does what I did, they're going to see that, well, you're just stupid. You don't actually look at the information you share. You don't do research. You don't prove it for yourself. And you're wrong. And that's why flat earth people are so dumb. I think we need to be more accurate in what we do. Now, there is speculation. So if you're making speculation or dealing with what you believe, then, as long as you tell people this is what I believe, or I'm just speculating, but then once it's proven to be absolutely false, then think that you should stop using that information, like this Taiwan plane. So what I did was I asked Rob Durham, who's been making some videos and talking about being accurate, and he's very detailed and he uses AutoCAD, and so I thought he would be the best person to ask to help with this. And what I asked him was how to tell what the height of the curve is, because what tends to happen is someone says that if we're looking at a distance of 60 miles, which is 2,400 feet, then the wall of this curve has to be 2,400 feet. And so I thought that was accurate before, but then I started to think about it again and not so sure that was true, and I wanted to just find out. So he drew up this image and explained it to me. So we've got the observer at A, and you notice that the observer is on top. The observer is always on top. So if you like being on the bottom, well, I'm sorry, you're just going to have to always be on top. You will never get that opportunity to be on the bottom. Thank you, gravity and science. And then there is the location that we are measuring to. And not only is there the curve between the two, but there is the straight line between the two. So we've got two different lines to deal with. Now B, this is the point of the apex in the curve. This is the highest point in the middle, and that's what we want to measure. So what we want to do, one of the best ways to do measurements is to use 90-degree triangles. So drawing a line down from the apex to this line between A and C at a 90-degree angle, and then drawing a line straight down from the observer at 90 degrees and connecting B to A, we create two 90-degree triangles, and they are connected between A and B. Now what we see here is that A and the B here is exactly half between A and C. So now we've got measurements for this line and this line. I'm not going to write this all out. And we've got the 90 degrees. So we're down here now. We've got A and B1 is 1/2 the line. Yep, got that. So line AA1, line AA1 is right here, is 1/2 of AC squared by 8 inches per mile. So this here, this line A to A1 is going to be the same height as B1. All right, now here it is simplified. How do we figure this out? If you're dealing with 60 miles, you can put any number in here. 60 miles is 2,400 feet of curve. So from A to C, if this is 60 miles, C is going to be a 2,400 foot drop in curve. And the simple way to do this is miles times 8, which is inches, because it's an 8-inch drop per mile, and then divide that by 12. That will give you, and it's pretty close. I mean, I've done this some longer distance. It does get a little inaccurate the further out you go, but it's still really close. So 60 miles is 2,400 feet. Now, if you want to find the height of the curve, well, we know that that is going to be half. Now you say, oh, well, half, 1,200 feet. But because of it's a curve, you can't just go half here. So if we did 30, which is half of 60, 30 times 30 times by 8 divided by 12, we have 600 feet. So the apex, the height of the curve, this wall, is 600 feet, not 2,400 feet. So we see it's significantly lower than what has been expected previously and what has been told. So you see, I mean, it's a pretty big error, really large difference between, say, 2,400 feet or 600 feet. So it's really simple to do. Rob went to AutoCAD. I just gave him these numbers just as an example, and so he ran it through, and he said for 30, it came out to 599 point something feet. So it's extremely close. The difference is so minimal that really doesn't make really much sense to just not call it 600. So it's close enough, very easy to do. You have your miles, you go half that miles and do the same number that you would for the drop in curve, and you will come out with your number. Pretty easy to do. So I'd like to see people start doing some more accurate information and caring about providing that, and let's do that going forward.